Hi, I Rohan, Simran, and Shubham will be presenting a project on recommend reinforcement learning for recommendation systems. We start by explaining how reinforcement learning helps overcome the challenges in conventional recommendation systems, specifically that of myopic recommendation, system bias, and the static nature of recommendations. Then we also explain how implementing reinforcement learning for this task poses its own challenges, like a large action space, partial observability of user state, noisy rewards that we can get, expensive exploration, and learning offline.
For our
Simran?
implementation, we look at the case study for Spotify. Spotify has a powerful data-driven algorithm that generates music recommendations for users. It would make recommendations based on metrics like whether the music was skipped and how long was it skipped and variations on so. For our project, we actually implement a version of deep reinforcement learning for list-wise recommendations, LIRT, on open source data from dataset, open source data from Spotify. The goal of the implementation would be to build a recommendation system that generates recommendations and minimizes the number of skip tracks in a recommended slate. The data, underlying data, is user sessions and track data. Yeah.
Yes. So actually, the first step in our sorry, I'll start over. So the first step in creating the recommendation agent is actually creating the item embedding. And in order to create the item embeddings, we take users' track history, and the input layer becomes all the tracks, so except the one which we remove randomly, and this randomly removed track becomes the output layer. And to actually generate these embeddings, we use the hidden layer, and this hidden layer gives us the item embedding. Once we have the item embeddings, we feed them into the GRU cells, and the output of these GRU cells is basically the user state vector. And the action space is actually very simple, which is just the top three track recommendations. And the reward here is 1 if the user does not skip the track, and it is 0 if the user skips. However, the reward is slightly tricky because when the system is deployed online, then the reward is captured from the environment, which is user's behavior. But when we are training this framework, we don't have the rewards, so we instead simulate it. And to simulate it, we have been using the cosine reward approach, which basically calculates the similarity based on the groups, which are the different possibilities of the rewards in our case.
Sorry, I was on mute. The underlying system is a DDPG algorithm where the actor is fed into state variables and in return turns out the weighted states, which is fed into the a neural network with combined. Let me show. Sorry. The underlying algorithm is essentially built atop of a classic DDPG algorithm, where we have two neural networks, one for the actor state and one for the critics. The actor neural network takes in the state vector and essentially in turn returns a weighted vector, which are then fed variables from the environment, which then are then fed into a neural network to provide a Q value for the weighted state and action pair.
Now, quickly going through the results and evaluations, we use two key metrics for our results. One is diversity, which measures the average dissimilarity between each pair of songs recommended in the recommendation list. And for this, we use the acoustic vectors. We achieve a diversity value of 10.6% for a DDPG framework. Then we measure skip rate, which tries to measure the percentage of recommended songs that were skipped by the user. And it's a value which we're trying to minimize. We obtain a value of 42.3% for DDPG framework, whereas the baseline value is 54.4%. That's the average skip rate in the entire data set. And then let's come to the limitations. One of the major limitations of this project was simulating the environment, and it had its own imperfections and complexities. Apart from this, we also observed that doing hyperparameter tuning for the DDPG framework did not yield significant improvements. And hence, we move to the future work where we will aim to explore new algorithms. One specific algorithm which comes to mind is stop K reinforce with off policy correction method, which has proven to be useful for YouTube recommendation. And since YouTube recommendation and Spotify recommendation is kind of similar to each other, we can try experimenting with this algorithm. And we'll also be using metrics like mean average precision and normalized discounted cumulative gain to objectively evaluate a recommendation system. Thank you.